So today we're going to move on and think about the opposite of exponents. So in Unit 7F, we're going to find and estimate square roots. Square roots, carrot is a root vegetable, right? Anyway, let's move on. So just to kind of give you an idea of, a place where this is used, imagine that you knew that a square room had an area of 100 feet squared. So this green carpeting in this room was 100 square feet. What is the length of the side? So this is sort of traditionally opposite of the typical area problem where you would get the side of the square. You'd have to multiply it by itself, length times width, and in a square, it's the same number to get the area. Now I've given you the area, and you have to give me one of the sides. So if all the sides are the same length in a square, what number times itself gives you 100? And what you should have said is 10. So 10 times 10 would give me the area of 100 feet squared. Oftentimes the mistake that is made here is that people just divide it by 2 and say it's 50, and they're thinking of adding. But remember, in our area formula, it's multiplication. So each side of the room would be 10 feet long. And basically what you just did is what's called the square root. So the opposite of squaring, the opposite of taking a side squared, would be to take the square root, and that's what we're going to talk about today. So a square root is shown by a radical sign. This is called the radical sign. Now, the number that's missing up here for a square root is an invisible 2. So just anytime you see this radical sign without an index, without a number in there, it's the invisible 2. The radical symbol is this black sign, and what is underneath the radical symbol is called the radicand. So you can have other roots besides square roots, cubed roots, fourth roots, fifth roots. We're going to talk a little bit about that in our next video, but today we're working with square roots. And what I want you to think of with that invisible 2 is you need a pair of identical twins. So when I look at what is the square root of 49, I'm looking for a number times its identical twin. That's what that 2 is going to stand for. That would give me 49. And you would say 7. But I need you to remember that -7 times -7, a negative times a negative, would also give you positive 49. So there are actually 2 answers to the square root of 49. There's a positive root and a negative root, a positive solution and a negative solution. Now, to be honest, in real world examples, oftentimes we're going to ignore that negative and just look at the positive, which is also called the principal root. So because 7 times 7 is 49, and -7 times -7 equals 49, the square root of 49 is +7 or -7. And you can write that in a nice, concise way by putting plus or minus 7. So here is a list of our perfect squares. They are the numbers whose square roots are whole numbers. So if you look down the blue here, these are all what are called perfect squares because the square root of 16 would be 4 or -4. Don't forget, I'm just giving the principal roots here. We just talked about the square root of 49, and basically I've got your perfect squares up to 400. And it's really good to be sort of familiar with these. So I'm going to guess that you're probably pretty much handle all of these, maybe even up to 12. But, just become familiar with your perfect squares. When we're working with square roots in this unit, this particular section of the unit, I should say, we're not using a calculator. So you're welcome to look at this list, however. Okay, so again, the positive root is also known as the principal root. I just want to say that, and that's the one that we will be using down the road when we're talking about applications to the real world usually. All right, so what is the square root of 121? I'm looking for what number times itself equals 121, and right here is 121. You can see that it's 11, but remember that there are 2 possibilities, 11 and -11, plus or minus 11. How about 64? That one's easier. Square root of 64 would be plus or minus 8, not 32 Oftentimes where there's an even number and we're not thinking, people divide it by 2. That's not what we're looking for. We're looking for a pair of identical twins, 8 and 8, that would multiply to give us 64. Now, when you see this fraction, don't let that, freak you out. If it is a division, you can cut that root kind of across and look at it as what's the square root of 49 over what's the square root of 100. And then it's just like 2 problems in one. So the square root of 49 we did on the last slide, and the square root of 100, and it would be plus or minus 7/10. When we put a decimal in there, people will often kind of make a mistake. Sometimes you can see that perfect square hiding in there. When that perfect square is there, you can say, well, it has something to do with 5. Now the question is, how many decimals do I put in front of that 5? So remember that when you multiply 0.5 times 0.5, yes, you would get a 25 there. And there are 2 decimal places, one after each 0.5, which would be 0.25. So the 0.25 square root would be 0.5. Now, what do you think about this one? So oftentimes the wrong answer is to put 0.005. It should be plus or minus 0.05. And here's kind of a clue. Do you see how there are four places after the decimal, and it is a square root? Remember the 2 here? So 4 divided by 2, I should have 2 places in my decimal. So if you were to take 0.05 times itself, 0.05, you would see the 25, and there would be 1, 2, 3, 4 places. So a square root of a decimal that has 4 places will give you a decimal that has 2, because when you multiply that back, you will get those 4 decimal places. Now, this isn't on my perfect square list there, but I do know it's 81, so it has something to do with 9. So 9 what? And did you realize that it's 90 plus or minus 90? So 9 times 9 gives me the 81, and that's 90 times 90. We're going to get those 2 zeros coming in at the end. So when you know your perfect squares, sometimes you can look at these kind of numbers, and without even heading to a calculator, which we're not going to do in this section, but you can kind of see the answer inside of those perfect squares. So I'm going to give you a chance to try a few right now, and we're just going to walk through each one, and I'll pause and see how you did. So the square root of 16. So did you put plus or minus 4? 4 times 4 is 16, negative 4 times negative 4 is 16. How about number 2? Did you put plus or minus 15? Again, 15 squared gives me 225. Negative 15 squared gives me 225. How about number 3? And did you get plus or minus 6 over 11? So that fraction we don't have to be afraid of. Okay, how about number 4? Okay, so I see the 169 in there. I know it has something to do with 13, but I would need to get those zeros on there, so it would be plus or minus 130, not 1,300. Okay, here come the decimals. Try number 5. I see the 121 hiding in there, so I know it has something to do with 11, but I need to get the decimal place in there. Notice there are 2 places after the decimal, and it's a square root, so there should only be 1 place after my answer. So did you put plus or minus 1.1? Now, to be honest, if you're uncertain, remember that the opposite, so when we take the square root to get back to the radicand, to get back to the number under the radical, you have to take your answer times itself. So you can always check yourself to make sure you have the right number of decimal places. Okay, number 6. All right, I see the 16 hiding in there. So I know it's going to be something to do with 4. But notice there's 1, 2, 3, 4, and it's the square root. 4 divided by 2, there should be 2 decimal places. So, 0.04. If you put 0.04, that's fine as well. Don't forget plus or minus. So now, number 7, what do you think? What I'm hoping is you kind of came up with a scratching your head kind of thought, because notice there's only 1 decimal place with 2. Something's up here. So you're tempted to say 0.3, but 0.3 times 0.3 would actually give you 0.09. So this one, unfortunately, is not going to come out to a nice number. I'm just going to show you what it would if be if you put it in the calculator. It would be plus or minus 0.948683298. It's an irrational number, and we're going to talk more about those coming up next. So just note that if you have one decimal place, we can't use this idea of figuring it out in our head from a perfect square. We're going to have to look at other methods. So speaking of other methods and speaking of non-perfect squares, at some point here you might have said, hey, what happens if it's not a perfect square? And so now we're going to talk about, again, not having a calculator. So we're going to talk about estimating. So 54 is not a perfect square. So we're going to estimate it, or you would approximate it with a calculator. But today we're going to talk about doing all of this without the calculator. So let's take that square root of 54 and think about it. And the first thing we're going to do is we're going to try to come up with like what whole number. Is it 8-ish or 12-ish, or what is it close to? So you think about the two perfect squares that this guy fits in between. So you go back to our list over here of our perfect squares. And if you find 54, notice that it's going to be in between 49 and 64. So, it's somewhere in between 7 and 8. So we're going to start with those two ideas of what's below it and what's above it. So the first perfect square less than 54 would be 49, and the square root of 49 is 7. So that's what we're going to kind of look at down here. And then the first perfect square greater than 54, we just saw it on the list, is 64, and the square root of 64 is 8. So we know that the square root of 54 is somewhere in between. And let's just start right now talking about, is it 7 or is it 8 if we were going to estimate to a whole number? So if you just look at the difference here, and I've already made it kind of obvious here on the number line, but 54 minus 49, there's only 5 numbers in between 49 and 54, where there are 10 numbers in between 54 and 64. So the square root of 54 is about 7. It's a little bit bigger than 7. So if you were asked just what is the whole number, you'd say 7-ish, right? But what if we want to get, more specific than that? What if we want to say 7 point what? So we know it has to be between 7.0 and less than 8.0. So if we want a decimal on there, is it 7.1? Is it 7.2? Is it 7.3? That's what we're looking for. So since it is 5 away from 49 and 10 away from 54, see there's 15 total, it looks to me to be about a third of the way. So I'm thinking it's somewhere like 7.3 or 7.4. That's where I'm thinking it is. So I'm going to, again, without a calculator, I'm trying to do this all estimating without a calculator. I'm going to take 7.3. I mean, if I was going to guess right now, I would just say 7.3. If I want to prove it, I would take 7.3 times itself. And I'd take 3 times 3 and write 9, and 3 times 7 and write 21. I'd put a 0 under the 9. 7 times 3 is 21. Hold the 2. 7 times 7 is 49, 50, 51. Add down. And then remember, there's 2 decimals to the right, so there's 2 decimals. So right now, look, I'm underestimated. I'm below the 54. By how much? Well, if I added 0.01, 1 cent to this, I'd have 30. So I'm below it. I mean, I'm going to show you the math, but I can do that in my head. If I added 0.01, I'd get to 30. So 0.71. So I'm under by 0.71. Would 7.4, the next biggest, be a better estimate? I'm not going to try 7.2 because I'm already below. So now I want to go bigger. Will I get closer to 54 if I do 7.4? So I'm going to multiply both those together, because the opposite of taking a square root is to square it. And I'm going to multiply it by itself. So I do the multiplication. 4 times 4 is 16. Hold the 1. 28 plus 1 would be 29. Put a 0 under the 6. I'd get 28. Hold the 2. 49 plus 2 is 51. I add down. put my decimals in, and notice this time, this one's easier to see. I'm over by how much? You can kind of see at 0.76. You really don't have to do, like I can do this math in my head, but that's basically the math I'm doing in my head. So it was really darn close here. But 7.3, is the better estimate because it is closer to that 54. So I'm just showing you that that's how you could estimate. But to be honest, if somebody's just asking me for a quick estimate, I would have jumped on the 7.3 because it's about, a third of the way. So it was kind of easy to see that. So I just wanted to talk about that estimating because it is an important skill to have to be able to go further. I mean, you could go again and say, well, now is it closer? What if I went to the 100th? I mean, so you could keep doing that, not that we're going to, but estimation is kind of a good skill. So what I need you to come out with today is what is a root? What is a square root? It's the opposite of the exponent. I need you to be able to know those perfect squares and be able to take the square root of those, and also to make an estimate, not only to the whole number as to which one is a non-perfect square closer to, but also to think one step further and can you put one decimal place on that? So that's what we're dealing with today, the opposite of exponents. Give it a try, and when I see you in your class, we'll practice a few more together. Have a great day, everybody.